Okay, hey guys. Here is a small video kind of recapping what we have already talked about this semester and what the videos this week were about. But also I'm going to do a little bit regarding next week and the new information you guys are going to learn. So this is all about balancing mole ratios and stoichiometry. And so I've got an example problem. It should be pretty easy to balance. We've done this multiple times in class, especially this example. We've got H2O2 makes water H2O. So I know I've got 2 hydrogens, 2 oxygens over here on the left on the reactant side. We know that the arrow is our divider between 2 hydrogens and 1 oxygen. So if we need these to balance, the only thing that's unbalanced is our oxygens. We go from having 2 oxygens to 1. So we multiply 1 by 2 to get 2, but then that makes 2 times 2, 4. Our hydrogens no longer match, which means we're going to have to put a big old 2 right here because 2 times 2 is 4, which means any place that we don't have a spot, we know we've got an imaginary 1 there. So hopefully that isn't new information. What some of you guys I've noticed are struggling with is the mole ratios. And that comes from these points that we just balanced. And so we can see in front of this hydrogen, we've got a big 2. That's coefficient also tells us that we have 2 moles of hydrogen. Same thing here. I've got a 1 coefficient for the oxygen. I know I have 1 mole for the oxygen. Water has a 2, so I know I've got 2 moles for water. Once we know how many moles we have, you can do whatever mole ratio combination you can think of. So if I needed the ratio between H2 and O2, let's say, I know that H2, we said we balanced it, we put a 2 in front, so we know we have 2 moles. Oxygen, when we balanced it, we put a 1 in front, I know I have 1 mole. So the ratio of H2 to O2 would be 2 to 1. If I wanted to do H2 to water, H2O, we said H2 has the 2 in front. We know it has 2 moles. But also water, whenever we balanced it, had a 2 in front. We know it has 2 moles. So the ratio would be 2 to 2. We can also rewrite this if we simplify it as 1 to 1. And that's because we could divide both of these by 2, and 2 divided by itself is 1. We know that. So now if we do a practice problem, if I begin an experiment with 10 grams of water, how many liters of water am I using? So in this, it gives me a starting value of 10 grams. That's the first step. I gotta find out what it gives me. I know it's 10 grams of water. And it wants to know how many liters. So I know I need to make my way 2 liters. So in this, I have kind of drawn out the chart we've been using in class. It's a little rough. Don't criticize my art skills. But if we're at mass, remember it gave us 10 grams of mass. And we need to make our way all the way over here to liters. There's no direct path connecting these two. Remember, the first step we got to do is go through moles. And so to do that, to get from mass to mole, I need to have the molar mass on the bottom with 1 mole up top. So if I go back to my problem, I know I've got the molar mass at the bottom, which if we look at water, I know that hydrogen has a mass of 1 gram, and I've got 2 of them, so I've got to multiply that by 2. So hydrogen has a total of 2 grams. Oxygen is going to have 16 grams. If we add these guys together, we know we've got a total of 18 grams. So if we have 18 grams of water, and that gives us 1 mole of water, now we can go from moles to liters. And we know that if we follow the arrow going 2 liters, we should have 1 mole at the bottom and 22.4 liters up top. And so if we multiply all this together, if I do 10 times 1 times 22.4, I know I should have 224. And then if I multiply 18 times 1, that's going to keep me with 18. 22.4 divided by 18 is going to be 12.4 total liters of water. So hopefully this itself is not new. This is hopefully review to what we've been doing already. What I want to kind of give you guys an introduction to is what we're going to be doing next. So I'm going to pull this over, going to hide this for a second. So first things first, we have a new equation. We've got to balance it again. So I have 4 things I'm dealing with here. I've got a lead, oxygen, hydrogen, and chlorine. Now, I can't keep my hydroxide together because I don't see hydroxide on this side. It has broken up from OH to H2O, which means I cannot count it the same, which means this 2 is going to have to distribute. So if we do our counting, I know I have 1 Pb, 1 lead, I've got an imaginary 1, 2 oxygens, 2 hydrogens because of that distribution. I also have 1 hydrogen here and 1 chlorine. So now the arrow is our divider. I know in total on this side, I have 3 hydrogens, 1 chlorine, 2 oxygen, and 1 lead. So now if we flip over to the product side, I've got 2 hydrogens because of this subscript, 1 hydrogen, or 1 oxygen because oxygen does not have 1. If anything does not have a subscript, we know it's got to be 1. So same thing for our lead, and our chlorine has got to be 2. So now we can do our balancing. The hardest thing is probably going to be our hydrogens. So we've got 2 hydrogens here and 1 hydrogen here, making a total of 3. We can actually make this 1 an even 2 by putting a 2 right in front of hydrochloric acid right there. By doing that, it's going to change our hydrogen and chlorine values and give us 2 hydrogens, 2 chlorines with a total of 4 hydrogens. And so now we can bounce to the other side. 2 can reach 4. It couldn't reach 3. And so we know that 2 times 2 will give us 4. And so that'll change our oxygens and our hydrogens, because remember, if you put it in front, it changes the whole compound. So we've got 4 hydrogens, 2 oxygens now. With our lead, we still have 1 and 1, and 2 chlorines, 2 chlorines. And so we know if we leave any place without a change, we're going to just put 1 out front. And so I'm going to erase these numbers here for the next part. So once we balance it, we know we have got our number of moles figured out too. So remember, these coefficients tell us how many moles we have. So we know we've got 1 mole of PbOH, 2 moles of HCl, 2 moles of water and 1 mole of PbCl2. And so now I'm going to bring back in this sticky note I hid a second ago. And it's got a problem on it for us. It says, if I begin an experiment with 10 grams of HCl, how much mass of PbOH2 do I have? And so this is going to kind of put us in a new spot, because in the past, we've always stayed with the same element we started with. We just changed what we were doing. Now we need to find the mass of a whole different compound. But all that does is add one extra step to our staircase. So I've got to start it the same way I normally do. I've got to put my given in the box. I've got 10 grams of HCl. And I'm going to make my little chart like usual, just like that. I'm going to put my starting point. When we look at the Y chart again, remember now we're going from mass back to mass. So we're staying just in this branch right here. And if I want to go from mass to mole, I've got to put the molar mass at the bottom, 1 mole on top. So for HCl, I know that hydrogen has a mass of 1 gram, chlorine has a mass of 35 grams. Add that together, we get a grand total of 36 grams of HCl. And that's going to give us 1 mole. And so we know that our units are going to cancel out. Now we can use these mole ratios that we've been finding to go from HCl to PbOH2. And so now that we're in moles, we just have to look at our problem we started and say, okay, when we balanced it, how many moles of HCl did I have? And we know that it's 2 because our coefficient was 2. So we've got 2 moles of HCl. And then I want to look at what I'm going to. So how many moles of PbOH2 do I have? And so we look back at our balanced equation. We didn't change it, so we put a 1 in front. That tells us we have 1 mole. And it wants to know the mass of PbOH2. So I can then go back. I've got 1 mole. I need to go to find the molar mass. I know that Pb has a mass of 207. Oxygen has a mass of 16 times 2, which we know is 32. Hydrogen has a mass of 1, and I've got 2 of them. And that gives me 2. So then if I add 207 plus 32 plus 2, I get a grand total of 241 grams. So now, again, we're just going to multiply everything on the top. So 241 times 10. And that's going to give us 2,410. I've got to multiply everything on the bottom. So 1 times 2 times 36. And that's going to give us 72. When I divide these two numbers, I'm going to get 33.47 grams of PbOH2. Okay, the only thing that's new is this block right here. Everything else we've done is just going from moles and grams and grams and moles and back and forth. The only thing is incorporating this mole ratio. Your assignment for next week is going to do a lot with this and implying this mole ratio into the stoichiometry that we've done. If you have any questions, please shoot me an email so that way the next video I make can be more directed towards that. All right, thanks guys. I hope you're having a good break.